Hello, folks. How are you all doing? Well, I hope. Root Beer here, looking at B3 from the Comc Canadian Open Mathematics Challenge from the year 2017. Regular decagon, A, B, C, D, E, F, G, H, I, J, has area 217 square units. That's kind of interesting. Determine the area in square units of the rectangle CDHI. So this rectangle that goes right across here. Now, I don't know a formula off the top of my head for the area of a regular 10-sided polygon. I'm sure I could use some trigonometry to figure it out, and someone out there probably who's watching might have that memorized. I don't think... I'm going to try and avoid doing that, but just out of curiosity, if you had sort of a really big polygon, how would you figure out an area? What I would do is, if it's regular, taking a little sort of triangular pie slice like this is going to be... It's going to be the same... So it's just going to be 10 copies of this pie slice, and then how do we figure out the area here? Well, the angle of each pie slice, because the pie slices are congruent, there's going to be 10 of them that go around a circle, so it'll be 2 pi by whatever size your polygon is, your n-gon. And then your side length over here, and this is enough, because it'll be isosceles. This is enough information to figure out the area of the triangle, and so you can then work out the total area, because it's going to be 10 times the area of such a triangle. Yeah, so that's the basics. So you could try and figure it out on the fly using trigonometry, but as I say, I'm going to try and avoid trigonometry if I can. If I have to, then at the end of the video I will work out this formula, and I might even work out the general one. But let's see what we can do without it. Okay. So instead, let's draw a nice copy of this thing. So it's a rectangle, go across. So that's 2 of the sides, and that leaves what? If it's 10 gone, it's going to leave 8 more sides. So we've got 1, 2. Well, actually, these sides are going to have to be a bit closer. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's sort of close. It's not perfect, but there it is. Okay, so here's my 10 gone, and I just want the area of this band, this rectangle here. Okay, so how can we figure this out? Well, I know the total area is 2017. I think probably a good strategy for something like this might be to break this down. So this band is going to, because it's 2 opposite sides, this band is going to contain in the center of this rectangle will be the center of my decagon. And so I've got these 2 red triangles, and they would be, well, sort of the same setup for trying to figure out the area. They would be 1/10. So each red triangle is 1/10 of the total area. Right? So that makes part of the band, but what about the blue area here? So I get 2 of those red bands, and then what about these blue areas? Well, I have a sneaking suspicion that they will also be the area of one of these red triangles. So let's look at an even bigger version of this rectangle. So if I just had a rectangle, I took the center of that rectangle, and let's call the dimensions of the rectangle maybe A and B. Shall we? So I know the total area of the rectangle is AB. Now what is the area of each of these 2 triangles, these 2 red triangles? Well, how would I figure that out? Well, it would be base, A, times height. And because we're looking at the center of the triangle, we drop a nice little perpendicular down here, the height is going to be B2. So each of the 2 red triangles here has an area of 1/2 base of A times height B over 2. So So there's AB over 4. So each triangle has 1/4 the area of the rectangle. So two of them together would be 1/2 the rectangle. And so what does that leave? The remaining now blue area, just to match with our original diagram, would also have an area half the rectangle. Right? Because it has to add up to the full A times B area of the rectangle. So the area of this rectangle is just going to be 4 times one of these. Actually, let's change the color again. One of these green triangles, these pie slice triangles, and we know those have an area of 2017 over 10. So the area of rectangle is 4 times the area of the pie slices, let's call them. And since there's 10 of those pie slices, they're 2017 over 10. So that's 4,068 over 10. And what did we want? Determine the area. Okay, in square units. Well, there it is. I suppose we could divide by 2. Could have divided by 2 earlier and left with 2 over 5. So that would be, what, 4,034 over 5. Can't simplify it anymore. And if you read the instructions, they do say, don't round. All answers should be kept exact. So 4,034 over 5, that's exactly how we're going to leave this. Okay? It's kind of interesting that band goes across. And we didn't really use the 10 at all. We just sort of used it for the dividing pie slices. So it'd be kind of interesting if we generalize the question and talk about sort of a regular 2n-gon. You'll always have opposite sides if there's an even number of sides. The same sort of pie slice reasoning should apply, and so a rectangular band across sort of the diameter of a regular 2n-gon should always be 4 of these pie slices, so 4 times the area over 2n, which I guess would always be 2a over n. And that's exactly what we saw here, but it's a neat little generalization of the problem. And I always like it when a problem makes me think even after I've done the problem. Okay, so that was B3. Up next will be question B4. Feel free to take a look at it ahead of time, and I will see you for more of the Open in the next video.